Hello, everybody. So I'm Christian. I work as a solution architect, lead engineer, many other side tasks at Deutsche Bank in a highly regulated environment. And I want to give you an introduction of what it means to work in such an environment. I want to start with what that environment actually looks like. I want to go into why we are that highly regulated, what it means for us. And I want to show you how we use Airflow to overcome some of these hurdles and how Airflow helps us in our day-to-day processing. Before I start that, when I signed up for this talk, I got an email from the organization committee, and they said, hey, here's all the information you need. It's in the Google Docs. Well, we're a pretty big Google Docs shop, and you would mean, hey, that should work, right? You should be able to go to Google Docs and download the application and all the information for speakers. But no, you can't, because, well, Deutsche Bank or banks are very sensitive with data. And if you go to Google Docs, you could theoretically upload data and you would lose it. And we don't want to risk that. So Google Docs, for me, a big no. And so are so many other things. So I need to get special permission to get to GitHub. I need special permission to use any kind of tools. So it's a challenge to do what you guys do maybe in a week. It takes us 3 months, half a year to do the same thing. And I'm going to give you a bit of an insight in why that is and how we try to overcome that. I represent only a small portion of Deutsche Bank. I want to make that clear. I'm not a platform team. I'm only a data provider for a bunch of our really critical use cases. That being said, let's dive into it. Deutsche Bank, we're one of the biggest euro clearing banks in the world. Why does that matter? Well, if you think of a payment and you think of a payment that you make to somebody, you usually do that within a country, and that payment flows from your bank to the receiver's bank, and there's no in-between hops. If you think of payments in a global environment, there's a lot of in-between hops. The payment network is like a normal computer network, and you can see payments as packages in that network. So a payment might travel from your bank. If you have a bank in the US, you want to make a euro payment, that payment travels from your bank to a correspondent bank or a hub or a hub in the network. And it travels maybe through Deutsche Bank to the target bank. So when we have a problem with our network or any application within that process, the impact is way bigger than just on our business. The impact is on a lot of these banks that rely on us to transport their messages. And because of the scale of the operation, just to give you an idea, we had one production incident. And I heard in the scribe talk, the quickest way to get attention in an incident is if you separate your clients from their money. Yeah, I can tell a few stories about that. We had a production incident where we haven't been able to process some portion of our payments for several hours. And one of the incident managers asks, hey, how much money are we out? And I said, well, somebody query the database and find me a number. Come back, 63 billion. I said oh yeah, 63 million, not that bad. It's no, it's a B, not an M. So these are the numbers that we deal with on a daily basis. So that is a massive impact, and that leads to a lot of regulations because, well, if we fail, we have an impact on the whole ecosystem. Thank God we only focus on corporations and financial institutes, which means on one side, we don't have any PII data, so no social security numbers, no credit card numbers, none of that. So that part is not our problem. But on the other side, that means that we have challenges of, hey, we want to operate our business 24/7. And we want to have an account in the US, but at the same time, we want an account statement when the business in Asia opens. Give us that account statement when we need it, not when you are done with your day. So we deal a lot with like large corporations and their global challenges, and we try to overcome that. And in that, we're offering services in 35 different countries, which means that we're dealing with 35 different regulators. Each of those regulators have roughly the same idea of what we can and what we cannot do. Again, to give you an example, if you have a bank account in the US, you will see FDIC insurance whenever you log in, and it's everywhere now. It's a new regulation that it needs to be displayed when you log into your account. What does that mean? FDIC ensures that the first $250,000 that you have in your account, if the bank goes bankrupt, is covered. Well, we do the same thing in Europe. In Germany, my home country, we have BaFin, Banken- und Finanzaufsicht, that has a very similar approach, but they cover a different amount, they have different regulations in how we deliver them the data. So it's not the same, but it's very similar. But these small differences make for a very complicated landscape that we deal with and that we have to account for. That being said, we also deal with a lot of internal complexity. We have 50 different payment systems. Why do we have 50 different payment systems? Well, we do checks, which is like that piece of paper where you write something on and somebody gets money like 7 weeks later. But we also do instant payments. Instant payments, well, we guarantee that we deliver the money to the receiver within 5 seconds. So we have a piece of paper on one side and something that you do on your smartphone, and you deliver in real time to the clients, and we enable like salary payments on a Sunday, something like that. So there's a vast complexity in that landscape. As you can imagine, as a bank, I was already introduced as a COBOL developer, and yes, indeed, I started as a COBOL developer. Haven't touched much of COBOL code in about 20 years, but I started as it, and there's still COBOL around. So we're dealing with applications that are really, really old. So I guess the majority, if I ask, what do you think is an old application? Raise your hands if you think 10 years is an old application. Okay. We wouldn't consider that old necessarily. We would say like, hey, that's hot off the press. If you get to the 30, yeah, that's where we're talking old. Okay. So it's, I think the pace that we're moving at is vastly different to what the rest of the IT industry moves at. What else? We have about 2 million accounts that we deal with, 50 million payments on those accounts. Not massive numbers by any means. But again, the complexity comes in if you think that every payment gets touched about 50 times in its life cycle. And we have to actually make sure that we get every part of the life cycle. Maybe not every of the 50 steps, but at least the important steps around the life cycle, because we have to demonstrate to our auditors that, hey, we know how that payment changed from A to B to C and how it ended up being paid out to that person in the end. So what are the regulatory challenges that we face? Completeness, accuracy, and timeliness. I think everybody has heard that. Yeah. But for us, that's a bit more at the heart of our operation. Because, well, if you have a bank statement, you don't want that to be wrong. Well, unless it's a debit that's missing. Then you're usually fine with it, right? But if your salary payment is supposed to come in on the 14th, and it's not on your account, you're very unhappy. Multiply that with reduced salary payments for large organizations. You can imagine how unhappy people are when the money doesn't arrive. So we have to take that a lot more serious. So why does completeness matter? Well, for example, we run AFC use cases, anti-financial crime use cases on top of our data. Completeness is very important in that regard, because if we miss one payment, and that payment could be a $1 billion payment to a organization that we're not supposed to pay to, that might be a big issue. So you can't look at it and like, hey, you've processed 50 million payments today, you scanned 49 million and almost all of them, but you missed the two critical ones. That's not going to fly. So our budget for completeness is actually 0. Accuracy is about the same topic. If you change the spelling of a name, and I'm a victim of that myself, because I have a German umlaut in my name, I had very many close calls of not getting on a plane because my name, instead of was changed from the German umlaut with OE to just an O. Well, the airline usually tells you, sorry, you can't board because that's not your name. Same applies to us. If we change a name on a payment and we can't prove why that name was changed, maybe an operator did that on purpose, but then we need to document it. So the accuracy of our data and how that data flows through our system needs to be documented and can't be wrong. Because again, if you run AFC, if you run statement generation, if you run critical tasks on top of that data, you will be held accountable by your clients and your regulators. And then we have a lot of local requirements. 35 different countries, potentially 35 different local requirements. So what do I mean when I say local requirements? Like one of the local requirements that we ran into, and that was kind of the first thing that I did in Google Cloud when we signed up, when we started putting data over, was data localization for India. The India requirement says, if you process payment data, you need to store that data in the country. Well, in that process, I learned about seismic zones in India. Why? Well, it turns out India has a lot of earthquakes. I didn't know that. I don't know if you do, but I learned about that. And there's a regulation which says, hey, you have to store data in 2 different seismic zones. When you first read that, and you're like, A, what is a seismic zone? B, what do the seismic zones in India even look like? And then C, where are the Google data centers? Turns out there's 2 Google data centers which are in different regions which fulfill the requirement. But if you know about BigQuery, replication across different zones, it's actually not that easy, and you can't query across. So we have to come up with some fancy ideas how you are complying with the regulation, but still can run your workloads. That alone, I can spend half an hour talking about it, so I'll not bore you to death with it. It's complicated. We also have you can't go to the public cloud. So there's a set of countries that we operate in that do not want us to take our data anywhere else than on-prem. Well, makes sense if you think about that there's maybe tension between countries and they're like, hey, if you put it on a cloud provider that sits in a country that we have no control over, we don't want you to do that with something as critical as payment data. So now we're stuck between, hey, we want to put all of that data in a central place. We want to be able to orchestrate and like run the data. We want to be able to run data pipelines and all that stuff. But at the same time, we have regulations that clearly say, well, you can do that for a good amount of your data, but not for all your data. So another complexity in our environment that forces us to go at a slower pace than you would usually go, because you always have to like talk to lawyers, compliance officers, whatever, that tell you, hey, that's actually the regulation in that country. That's what you can do and that's what you can't do. Retention periods. Who's aware of GDPR? If you operate in Europe, I'm pretty sure you have a good idea. It's interesting. GDPR tells you that there's a right to forget. So you can actually ask for your data to be deleted. Well, if you're a global operating organization, you might end up with a scenario where on one side, GDPR tells you that you need to delete the data. On the other side, you might have a regulation because we're in the US, that says you have to keep that data for 10 years for tax purposes. What are you going to do? I'm not a lawyer, I'm not going to answer that question, but it's one of the issues that we have on a regular basis. It's like, Can we do it? Can we delete it? Do we have to keep it? If we keep it, how do we keep it? Very interesting. And that access policies on that kind of data is a key topic. I think everybody can imagine. You don't want anybody else to see your banking data. And so want many of the big companies. They don't want that people unnecessarily see their data and, well, maybe come up with fancy ideas what they might be doing or what they might not be doing. So regulation around who can see what data, especially again on country level. If you operate with Swiss data and you're a US person, that doesn't mix. So there's certain data that I will never be able to see because I'm in the US. So now to the point of why we're here. What do we do with Airflow? Actually, not that much. It's actually, after looking at all the fancy things that people do, all the orchestration and everything, it's actually very basic what we do. We do a lot of, hey, run this workflow whenever this file arrives, kick off a few Spark jobs, run a bit of orchestration, but it's none of the fancy things that you would see. But based on what I just said, the environment we work in, yeah, it's obvious. Because we can't use a lot of these features and we can't do a lot of these things because, well, we need to get audit approval, we need to get regulators to comply with it and be happy with us doing this. So what we do is more on the basic side and we're catching up slowly as we speak. That being said, we still use it a lot. And I was talking about the COBOL data coming in. That's one of the use cases that we have. So we get a lot of end-of-day batch data where we get a lot of files from upstream systems and we orchestrate workflows around it where we ingest the data and we make it available in a much more friendly JSON-based schema for consumers downstream. And we also make it that you don't have to talk to 50 systems, but you get a cohesive data set, single place. Again, timing challenges and everything still apply, and we're definitely looking forward to getting assets in the near future, just about a year from now, when we finally get Airflow 3, that we can use some of these new features to actually make our pipelines a lot more dynamic. We also have intraday streaming pipelines. Well, now you're going to ask yourself, why are you orchestrating intraday streaming pipelines with Airflow? Well, I have one of our DAGs on the next slide, and I will show you why that is. And the main reason is the next point for our support access. Nobody gets access to anything because, well, we don't want people to manipulate. So getting read access is hard. Getting write access is basically impossible. So anything that you do needs to go through 4 eyes. So it's very hard to do that proactively, getting approvals for a click on a UI. So we record every screen session. So when you get production access and you're allowed to click a button on a Airflow DAG to say, hey, run this DAG again, that is going to be video recorded and some auditor is going to look at it and goes like, hey, you had the right ticket in place to actually click that button. So because of that, we use Airflow as a single pane of glass for our support to actually look at all our workflows. And having a streaming workflow orchestrated through that actually gives us exactly that single pane of glass. And then we use Airflow as an odd job runner. For example, creating database tables. We initially were asked to hey, use Terraform. If you've ever tried to do Terraform create table, and you have an alias in the table, and the Terraform state doesn't match your table, the next thing that happens is, exactly, drop table. I've lost a few tables in UAT because I missed the drop table part of the Airflow, of the Terraform command chain. So now you're like, hey, why don't you just do it from your GitHub workflow? Well, GitHub workflow doesn't have permission to do DDL operations. So what's the solution? Airflow. Airflow comes in, we can run DDL operations from Airflow. Great, cool. We also have this like, hey, run a Spark job and test. I got asked by one of the Google colleagues, like, hey, we implemented a new feature with Iceberg. Can you run a Spark test for us? I'm like, sure. Oh, hold on, I can't run a Dataproc job because I don't have permission, even in test. So what's the best way of doing it? Well, bash operator is your best friend. Small DAG, run it, all good. Same with creating a search index in a 250 terabyte table in production. Well, bash operator, BQ, create search index, happy days. So that's the DAG. Looks mighty complicated, right? Well, it's not. And the only reason why we have the DAG is for the purpose of A, the single pane of glass. If the DAG fails and our intraday pipeline goes down, we can actually just restart it from there. And it has one magic feature, which is configure a key store. Basically, what we do when we start the DAG, we pull a new SSL certificate from our internal SSL authority, and we make sure that we can actually connect to our Kafka server. And if for whatever reason the certificate gets revoked, just one click of a button, we get a new certificate, happy days. And then the last one, our end of day loading. That's why we are so happy to see that there's also assets reacting to external events. We built that ourselves by the means of having one DAG that pulls from Kafka and spins off more DAGs. But we put in a few cool features here. For example, our data is always to be immutable. We can't change the data, but we still do data fixes. So how does that work? We tag every data version that we have in the table, and we say, like, this is that version, that's that version, that's that version, which also means we can't do upsert. Because if you do an upsert, you just overwrote the old data. Now, if an order that comes in and said, like, hey, LFC, you ran your workflow on this data, why did you get to that result? I looked at the data, it looks different now. So we can't do that. So what we basically do is like we use the magic here to create a DAC run that can only run once because of the DAC run ID that we assign it. And then we basically make sure that the job run is idempotent so that the file can only be loaded once. There's no risk of running the same DAC twice at the same time or anything like that. And then at the end, this C-code topic is we basically send out a notification to the next in line and say, like, hey, we published that data, we're good to go. So that was it. I know very little Airflow actually, but it's an insight of what it means to work in a highly regulated environment. And I hope you enjoyed it. If you have any questions, send me an email. And yeah, thank you.